There is a well outside Midland, Texas that did everything right. It found oil. It produced oil. Somebody made money on it. By every measure the industry uses, it worked. And when that well is finally plugged and abandoned, roughly 90% of the oil it was drilled into will still be down there. Not oil it missed. Not oil somewhere else. Oil in the rock that well is sitting in, that nobody will ever get out. That is not a bad well. That is a normal well. Across 28 tight oil plays in the United States, the recovery factor, the share of the oil in the rock that actually reaches the surface, is under 10% in every single one. In shale, the average is somewhere between 3 and 10. A conventional oil field gives back around a third of what it holds. West Texas shale gives back a 20th, which is strange because the Permian Basin is not a marginal place. It runs under West Texas and southeastern New Mexico and produces about 6.7 million barrels of crude a day. That is more than Iraq, more than the United Arab Emirates, more than any OPEC member except Saudi Arabia. Something close to half of all the oil the United States produces comes out of this one basin. It is the most intensely drilled ground on the face of the earth. Tens of thousands of horizontal wells, laterals running 2 miles sideways through the rock. An industry that has spent 15 years and hundreds of billions of dollars learning to squeeze it. And it still leaves 9 barrels behind for everyone it takes. So where does it go? The answer is not that the oil is unfinished. This is not Colorado. There is no half-cooked organic sludge in the Permian. The oil under Midland is real crude. It is liquid. It is exactly the thing you would pump if you could get near it. The problem is that you cannot get near it. 270 million years ago, this was a warm inland sea on the edge of a supercontinent, with a reef system around its rim and deep, still, oxygen-starved water in the middle. Organic material rained down into that basin and got buried. But it got buried in mud. Fine-grained, compacted, almost airless mud that eventually became shale. Over millions of years, the heat did its work, and the organic matter converted properly into oil. And then the oil stayed exactly where it was made. In a conventional field, oil migrates. It seeps upward through porous rock until it hits something impermeable and pools underneath it. And that pool is what a drill bit is looking for. The oil collects itself into a reservoir, and you tap the reservoir. Permian shale never let that happen. The oil formed inside rock so tight that it could not move through it. There is no pool. There is no reservoir. There is oil distributed through solid rock at a scale you would need a microscope to see. The number that governs all of this is permeability, how easily fluid moves through rock. A good conventional reservoir has permeability measured in darcies. Shale is measured in nanodarcies. That is a billionth of the same unit. At that scale, oil does not flow. Over the lifetime of a well, oil sitting 50 feet from the wellbore in shale will not travel 50 feet. It will barely travel at all, which is what fracking is actually for. It is easy to assume hydraulic fracturing is a way of getting oil out of rock. It is not. It is a way of getting the rock closer to the well. You pump water and sand down at enough pressure to crack the shale, and the sand props those cracks open, and you have manufactured a network of artificial pathways through stone that had none. Oil within a short distance of a crack can now reach the well, and oil that is not within a short distance of a crack stays where it is, forever. You can watch this happen in the production data. A new Permian well comes on strong. That is the part that makes headlines. Then, it falls off a cliff. Shale wells routinely lose 80 to 90% of their output within the first year or two. The rock immediately around the fractures drains, and there is nothing behind it to replace what came out. Which is why the Permian works the way it does. Every one of those tens of thousands of wells is a short, sharp burn. And the only way to hold basin production flat is to keep drilling new ones faster than the old ones die. That is the treadmill Midland and Odessa live on. Not the price of oil in some abstract sense. The drilling rate. When rigs move in, the RV parks fill, and the restaurants can't hire fast enough. When rigs stop, it does not decline gently. It stops. And it is also why operators started drilling wells closer and closer together. If the drainage radius around each fracture is small, you place more fractures. Push that too far, and the new wells start pulling on rock the old wells already depressurized. The industry calls it parent-child interference, and it is the sound of a basin running out of undrained rock rather than running out of oil. Now the scale. A University of Texas Bureau of Economic Geology assessment of the basin's conventional reservoirs estimated they held about 105.7 billion barrels at discovery. It projected that when those fields are finally depleted, around 74.5 billion barrels would still be in the ground. And 88% of that stranded oil sits shallower than 8,000 feet. Not deep, not exotic, not hard to reach. Right there, above the depth, most of the basin is already drilled to. 74 billion barrels left behind in the conventional reservoirs alone before you count a single shale well. For comparison, the entire United States holds somewhere in the region of 40 billion barrels of proven reserves. The oil the Permian is expected to abandon is larger than the oil the country officially claims to have. That is the untapped field. It is not hidden. It is not undiscovered. It has been mapped, drilled through, and left, which raises the obvious question. If it is right there, and it is real crude, and the wells are already drilled, why does nobody go back for it? Because everything that would move that oil costs more than the oil is worth. The Permian already hosts the largest carbon dioxide flooding operation in the United States. You inject CO2 into a depleted conventional reservoir, it mixes with the oil, thins it, and pushes it toward a producing well. It works. It has worked since the 70s. But it needs a source of CO2, a pipeline network to move it, decades of patience, and a reservoir that behaves. And it only works in porous carbonate rock, not in Nanodarcy shale. For shale, the leading idea is cyclic gas injection, Huff and Puff. You force gas into a spent well, shut it in, let the gas soak into the rock and swell what oil is trapped there, then open the well and produce it back. EOG converted around 150 wells in South Texas and reported real gains. But the arithmetic is brutal. A recovery factor of 7% means a single percentage point of improvement is a 14% increase in everything the well will ever produce. That is enormous. It is also, across a basin, the difference between a marginal experiment and a second oil boom. And after 15 years of trying, nobody has made it work at scale in shale. There is movement, though. In January 2026, the USGS published a new assessment of the Woodford and Barnett shales inside the Permian, formations that sit far below the ones everyone is drilling now, 18 to 20,000 feet down. It found 1.6 billion barrels of technically recoverable oil and 28.3 trillion cubic feet of gas. The oil figure amounts to about 10 weeks of American consumption. Those formations have been produced since the late 90s, and in that entire time, they have yielded roughly 26 million barrels one day. And in 2026, the National Energy Technology Laboratory has been publishing work aimed squarely at the 90%. New methods for measuring exactly what fluid is left in the rock after fracking, on the theory that you cannot recover what you cannot see. The Permian's own operators have started describing the next phase of the basin in exactly those terms. Not new acreage, not deeper targets, the oil already underneath the wells they own. So this is the shape of it. The most productive oil region on Earth is running on 1/10 of what it is standing on. The other 9/10 is not a mystery, not a frontier, not a reserve waiting for a better price. It is oil that everyone agrees is there, in rock that has already been paid for, sitting inches away from a steel pipe that goes to the surface. And a few inches in rock measured in nanodarcies may as well be a few miles. Somewhere out past Midland, there is a pump jack turning over on a lease that has been producing since the Eisenhower administration, and a horizontal well half a mile away that was fracked last spring and has already given up most of what it will ever give. Under both of them is more oil than either will ever touch, not because we cannot find it, because it will not move. If you found this interesting, subscribe and tell me which place we should look at next.